Welcome to You Should Avoid Symbol Creep in AL. Hey, I'm Eric, and in this video I'm going to talk about a thing that I call symbol creep. They may have other names in other places by other people, but that's how I call it. Let me start at the beginning. So when we have an app, we try to tie that app to specific versions of the runtime, to specific versions of the application, and so on, to control the app and make sure that what we have it will run where we think it will run. But quite often it ends up with some weird compilation errors anyway when they're deploying an app. They thought that there's no issues here. So let me show you. Here's an app. Yeah, I make it so big so you can see. This is the point of sale app. If you haven't seen the point of sale app, you should subscribe to the channel. There's lots of great videos here. The point of sale app is one of the things that we made on the channel a while back, and it's a poor man's point of sale system in PC. Anyway, so this is an old app, but I, as the app's creator, decided that this app should work on runtime 5.0. This should work on version 16 of BC. You see, 10 months ago. Like, that's a lifespan in BC time. Because maybe I have some on-prem customers who are running that version. So I want my app to stay compatible with version 16. But the app is of course developing, and at some point somebody added some new stuff to the app. Here, a very innocent looking page extension. Doesn't really matter what it is, and we can see that this thing has no problem with being on a runtime 5.0 and version 16. So of course we can compile this guy, we get a package, and I send it off to my version 16 customers. And they then come back and said, hey Eric, the point of sale app will not upgrade, it will not install the new app file. Because it says something about dimension correction schedule doesn't exist. Which is correct, because you see this page extends a page that came in version 18. So why will my app compile with this? And the place we need to look, what we need to look at is actually over here in the AL packages, as depending on how you're controlling this, your AL packages folder might suddenly look something like this. So you can see here that there's a bunch of apps here. Apparently this app is also using Avalero tags and using the SharePoint connector and using some continuous stuff and WSFN from eFocus, and there's some WooCommerce, and there's a bunch of Microsoft symbols. And the reason for all these especially is that when we try to deploy to a test sandbox, you get symbols downloaded. So the AL compiler is very simple downloading happy. I don't know how to explain this in a nice way. Of course you can do download symbols and you'll get symbols. And in this case, I have a Docker running and it's version 18. So I get version 18, I already have those. But at some point I might get 19 because that's what I'm using at some point. So unless you are careful, then the symbols you have here might not match what you think they should match. So suddenly, if we had this app, so that should work on version 18. So let me do some move around here. I'm gonna move, let's move the version 18 apps out of here. So now they're gone. So when you do external manipulation with the files that are in the AL project, you are totally messing up the AL compiler. So the only reasonable thing to do is, as soon as if you copy paste files or you do stuff not inside VS Code, but you do it outside of VS Code, you might as well do the reload window, because the compiler is totally gets confused. In this case, I reloaded, and then let's just see when this is done thinking. Activating all my extensions. We can also try to compile at this point, I guess. Compile. And you see all reference symbols are already downloaded. Sometimes when you start a compilation the first time, it will just download against, it will ask you if you have more than one target, it will ask you targeting, it will download stuff. Come on, you can do this, AL compiler. Boom. So now we have a target for a page extension that is not there, and we got the squiggly lines on this one, because now the symbols that had polluted my system suddenly were gone. So the natural question is now, so how do we avoid this? And that really depends on how you do your app management. If your app, let's say, if my base version is that I want to support version 16 and up in my app, and right now I want to just create one app file that works on 16, 17, 18. Then 16 is my base functionality. I should never have symbols that are not 16 available. But due to the way that the eagerness of downloading symbols, you gotta keep an eye on this one. If you there's different schools. Some people check in symbols to source control, others don't. If you have a build pipeline where you can select the version 16, you can download the symbols from version 16 and add to your app at compilation time. That's a great idea, because that means that you're secure that you're actually the artifacts that you're compiling are against the correct version of the app. So if somebody on their local machine are working and they do the symbols and suddenly we have the 18 stuff, and they maybe the example here is over the top, because it, of course, that dimension correction, that was a feature in 18, but there are more subtle changes, such as functions in system application that gains an overload at some point. If you remember another video we did on the channel about actually making a pull request to the system application, where we added overloads to the base 64 function. If I go in here and I do base 64 code unit, code unit base 64, come on BC. Come on. This also, by the way, this says longer. It seems that it takes longer the more you have, which might make sense. I know that is called base 64. Wow, I broke. See that? I broke the compiler. Interesting. Maybe you should reload. See if this is better. See. Anyway, so what we had on this one. Oh, we needed to load again. Come on, BC. Activating extensions. Activating extensions. Okay, now I'm just going to do something. Instead of us waiting for this, I'm just going to delete all those packages here, reload the page, download the symbols. As soon as AL is activated. Maybe I really broke it. That would not be the first video where that happened. Download symbols. Let's see if we can get the version 18 symbols in here again. Sorry guys, this always ends up in taking just a bit of time here. Anyway, there we go. Now we're getting some symbols. So let's see if we're ever gonna get something useful here. Loading, loading, loading. Come on, BZ. Oh, there we go. Actually, I broke it again, but let's ignore that. So if we can see here that this guy has 7 overloads. I'm sorry about that, took a minute. Has 7 overloads because we added some overloads in a pull request. So sometimes it's very subtle that, okay, I'm actually using the 2 base that has text encoding on, because that was in the symbols that I ended up having on my machine, and that works perfectly, and I committed it, and then the build pipeline suddenly broke. If you have a build pipeline, or if you don't have a build pipeline that does the proper testing, you might only find this breaking when a customer tries to install it. So in conclusion, symbol creep is a thing, and I've seen it in a lot of cases. People are suddenly getting confused, and I get an app file from an ISV, and it is supposed to work on version 16 or 17 or something like that, and it doesn't work because something came into it, but it was actually correct. You know, the app file has app.json had the right one, but something crept in there. So that's simple creep. Think about it and see if you can avoid it. That will make your apps way more predictable. Anyway, that's it for this video. Have fun, and I'll see you in the next one. Cheers.